it's crazy, but it's
You're watching Channel Z, the world's leading zombie apocalypse channel. Broadcasting live from Studio Z.
Makes me act the way I do.
And welcome. Welcome to another late November episode of the Dr. Z Show on Channel Z. As always, I am your host, Dr. Z, aka Joe Alcock, where in my day job, I am an emergency physician at the University of New Mexico here in Albuquerque, New Mexico. Today, we're going to talk about some fun things involving brains and pain. And in fact, the title of today's episode is No Brain, No Pain. And we'll be joined a little bit later by Dr. Robyn Crook, who's a neuroscientist and evolutionary biologist. And of course, Athena, octopus, as always, will be in the background. Hi, Athena.
Hey, Joe. I'm so excited about this show today.
Me too. I think this is going to be a really, really fun one.
So,
to know about pain.
Yeah, and do zombies feel pain? I mean, I personally, I'm confused. It seems like some zombies feel pain and other zombies don't feel pain. And I really need a pain expert to clear it up for me.
I agree. Until this morning, I assumed that zombies didn't feel pain, but I've been disabused of that notion by various zombie experts that we may hear from a little bit later. But yeah, I'm super excited, of course, to introduce Robyn Crook, who will be joining us here in just a second. Dr. Crook was educated at the University of Melbourne and then the City College of New York, where she got her PhD, and then on to University of Texas, and then finally the San Francisco State University, where she studies cephalopods. Let's bring Robyn into this picture here.
Good morning.
Well, hi, Robyn, and is it okay if I call you Robyn?
Absolutely.
Terrific. So we're gonna jump right in, I think, and pose the question: do zombies feel pain? Like, what is up with that? What do you think? Do you have any opinion about zombies and whether they feel pain or not?
So I have to say, I'm not a zombie expert, but I've been chatting with you guys, and I think, so one of the challenges with deciding whether an animal or a zombie or a person is experiencing pain is trying to figure out what they're feeling when they're performing a certain behavior. And so we were talking about, do zombies react if something bad happens to them?
Right.
But that doesn't necessarily mean that even if they do react, that they're sort of aware in an emotional suffering sense that something bad has happened to them. So pain is divided into these two worlds of nociception, which is a reflex kind of unconscious response that nearly all animals have. And then pain is this subjective experience associated with that, which really requires a high functioning brain. So only some animals are capable of that. And so I think it depends a bit on how the zombie's brain is working.
So it really, if one is experiencing pain and has this sort of central nervous system experience of pain, then you have to have a brain to do that, right? So that would indicate that zombies maybe have brains. I think that's really kind of again up for debate.
Yeah, probably. It seems like there's a lot of variation in zombie behavior, so it's perhaps not a simple question.
Right.
Yeah. So if we think about like zombies in the movies and in TV shows, some of them seem really oblivious to like major bodily harm, like, oh, like an arm is cut off, they don't care. Right. While others, there's some implication at least that pain is part of their experience. And so, it seems like there might be a lot of sort of diversity of experience of pain that's happening in the zombie world.
I did want to ask you, Robyn, about supposing we wanted to research something about zombies and use them as research subjects. What are the ethics of working on an organism that can experience pain? I know you've done some of this with your work, and as I mentioned, you study mostly cephalopods, squid and octopi, and even nautiluses. Can you jump in and tell us something about that?
Yeah, it is one of the big questions in invertebrate research at the moment, is how do you treat animals in the most ethical way? Because it's certainly the case that as biomedical researchers, we work on animals that experience pain. In order to study pain to produce treatments for people, we work on animals that feel pain, like laboratory rats and mice. And the question is, once you go a long way from mammals, what is the similarity of subjective experience in an animal that seems totally alien to us, like an octopus? And that's one of the questions that we work on. In terms of the ethics of working with zombies, you would reasonably need to give them some kind of protection from unnecessary suffering. I think that's a universal thing with any researcher, that you want to make sure that your animal is not experiencing unnecessary distress. If zombies are truly incapable of experiencing the suffering emotional component of pain, that does relieve some of the ethical concerns, where you can perhaps do more invasive procedures without necessarily having to provide analgesia if the zombie is insensitive.
We have some questions here kind of along these lines. So, one is, do you need IRB approval for zombie studies? Joe, I know this is something that you've actually thought quite a bit about. And, it kind of ties into this question also from Pam about, would you use zombies as a model organism for studying pain? So maybe Robyn, you can first jump in, and then we can talk a little more about, IRB approval in zombie studies as well.
So IRB approval is for humans. There's a different set of regulations for animals, and it kind of seems like zombies might fall somewhere in the middle in terms of their experience. I think most researchers, though, would rather err on the side of caution, and there's not much harm in having an IRB approval if the animal or the zombie doesn't feel pain, but there's a lot of harm in not having it if they do, right? So, I probably would request IRB approval for working on zombies. Would they be a good model organism? I think it depends on how their brain is functioning. If they have all of the machinery of pain, but for whatever reason they just are not suffering because of it, then they might be a great model organism to understand the neural sort of mechanisms of pain. But ultimately, we want to treat pain in humans as a subjective emotional experience. And so an animal that lacks that is never going to be a perfect model of pain, no matter how convenient or freely available zombies might be. They might not be ideal.
That's really interesting, Robyn. Hey, could you just back up a little bit and tell us a little bit about why I think cephalopods are a good model organism for pain, since they do have brains that are so completely different from ours? So to my mind, as an evolutionary biologist, that's what makes them so important and interesting as a comparative model. When we look at pain experience or any other part of the nervous system, really, in our typical vertebrate model animals, we're looking at brains that all evolved in very much the same way. Every vertebrate brain is very similar. Octopuses and squid and cuttlefish, they diverged from the vertebrate lineage before there were neurons, and so their brain has evolved completely independently. It's arranged completely independently. It does things totally differently. And over the course of evolution, it turns out that a lot of the sort of things that they need to do are similar to things that we need to do. And so there's very interesting, questions that we can ask about what are the fundamental kind of universal principles of complex brains. And that's really the rationale for working with cephalopods. So when you ask about complex human traits or vertebrate traits, what is the kind of outside comparison that we can find in cephalopods that might reveal these fundamental organizing principles? So even though the architecture of their brains is completely different, some of the functional aspects are the same? Yeah, absolutely. When you look at, the way that they process touch, the way that their visual system works, their eye is this wonderful example of pure convergent evolution where it's very similar to a vertebrate eye, but independently evolved. And so a lot of the things that an octopus needs to do, find its way around, find food, navigate a complex body in a complex environment, is very similar to what we need to do. So understanding those similarities is a big, interesting question. Yeah, with octopi, I mean, in a way, a lot of their brains is like it's more in their bodies, right? So like they have like truly embodied cognition, kind of in a way that we don't. It's a controversial question. So they definitely do have a lot of peripheral nervous system, and there's always people talking about how their arms have a mind of their own. In a lot of ways, the arm is very similar to our spinal cord, though. Our spinal cord does a lot of things independently of the central brain, and octopus arms do the same kind of thing. The arm itself doesn't learn and remember. The arm itself doesn't make complex decisions. All of that is still mediated by the octopus central brain. But a lot of the fine movements and things are done independently, which is very cool. Yeah, that's awesome. Squid can learn from pain too, and you've also speculated that there could be some evolutionary adaptationist reason for chronic pain. Do you want to talk about that? Yeah, so I should say, before I worked at cephalopods, I worked in biomedical pain research, looking at how to treat chronic pain and why chronic pain is such an intractable, difficult to treat problem. And one of the sort of
one of the overriding philosophies in biomedical pain research is that chronic pain is purely maladaptive. It's just a disease state. It doesn't have any natural function, and we should just get rid of it if we can. But then, being an evolutionary biologist in pain, it was interesting to me that, this thing that's very intractable, it's like the nervous system is almost designed to have this chronic pain state happen. I wanted to know, well, why would that be the case? And when we look at other animals that are out there living their lives subject to natural selection in a way that we as humans are no longer, can we find reasons that chronic pain might be so prevalent? What does it do for the animal? And it turns out that when you look at an animal like a squid, which is out there living its life with predators and injuries and all of the bad things that happen, when you have chronic pain happening in a squid, it protects them from predators. It gives them these long-term behavioral changes that makes them a little bit more touchy in the presence of danger. And that translates to a survival advantage. So perhaps chronic pain is intractable because it is adaptive.
And I wonder, maybe people with chronic pain could better avoid zombies.
Well, yes. I mean, chronic pain can make people hypersensitive to danger, that often manifests as anxiety. It can manifest as PTSD. Chronic pain has a host of cognitive sort of correlates with it. But it also can dull sensation. It can dull awareness of the world around us because we're so focused on this kind of introversion of experiencing the pain that it can stop us from paying attention to our surroundings. So it's probably not a simple, straightforward question whether it would be protective against zombies because it is very distracting.
Which kind of then brings up the question actually of, with zombies, is it possible that part of their unusual behavior is, due to the fact that they are in chronic pain?
It's possible. If you look at the behavior of zombies, they do seem to be, sort of mindless, thrashing about solely in pursuit of brains, which I think the hypothesis might be that they're consuming brains because they contain some kind of endogenous painkiller that relieves the zombie's pain. So I guess that is a possibility. I don't know.
That actually brings me to one other possibility. We explored whether zombification might be the result of a pathogen, a virus or a bacterium or maybe a fungus during the ZAM conference, which we had last month. And there are some good examples of organisms that destroy pain-sensing neurons as part of their virulence program. Certainly leprosy is maybe the canonical example of this, but also even recently it's been shown that SARS CoV-2 inhibits pain. There's a recent research study that shows that there's a mechanism by which it impairs the pain-sensing sensory neurons, the nociceptors. And this may actually give it a survival advantage when it's trying to get around the immune system. So that makes me wonder whether maybe the absence of pain in zombies could be the result of one of these pain-dulling infections. Just want to throw that out there.
Yeah, it's definitely possible. If you think about, what is the goal of a pathogen? It's to be spread. It's to get from one host to the other. And if we think of pain as being protective as a way of alerting us to danger and doing something, to get rid of it, if the pathogen is dulling pain sensation, it has a better chance of taking hold of the host, such that it can then infect it to a reasonable level to then infect somebody new, right? So if you can stop the protective purpose of pain, then it makes sense that the pathogen would do better. So yeah, maybe that's why zombies are impervious to pain, so that they can spread zombification.
Maybe, yeah.
Right.
Go ahead, Athena.
Oh, I was just going to say, if you're feeling great and, then you're just more likely to be out and about where you could have the opportunity to transmit versus if you're, in pain, I think you're more likely to, stay home, to not go out, to, not feel as motivated to be social. Right. And those things could have a big influence on the likelihood of transmission of a pathogen.
Definitely. Yeah, pain promotes risk-averse behavior. It drives us to stay home and protect ourselves and not necessarily be out engaging in dangerous pursuits. And so if we think about a pathogen that's perhaps spread by direct bodily fluid contact, if it can stop those kind of protective instincts to not go out and engage in violent behavior like zombies do, then it would have a better chance of spreading itself for sure.
That makes me think about the behavioral immune system, that one way that certain pathogens may actually gain an advantage is by altering the behavior of their hosts. And there are plenty of good examples of this. The most famous one, of course, is the fungus that infects the ant, the cordyceps fungus that hijacks the neurobiology of its ant host. So it's possible that maybe certain kinds of pathogens or infections hijack our neurobiology in ways that give them an advantage by disabling the behavioral immune system. And it makes me, go ahead, Athena, I think you were going to jump in.
Well, Dr. Zed, we have actually a bunch of questions in the comments kind of related to these issues. So, one of them is, Dave is asking, how does leprosy affect pain exactly? You sort of made a reference to that. And there's also a question from Pam Winfrey. She earlier asked about whether or maybe it wasn't her. Somebody asked about the jewel wasp and the zombification of cockroaches and sort of what's going on with pain there. So Dr. Zed, maybe we could just take a minute or two to talk about like pain and infection and parasitism, because I think there's a little bit of kind of big picture here that it would be great to chat about with the audience.
There are so many different directions and fun things that we could talk about here. I think the leprosy example kind of highlights that the fact that certain pathogens seem to gain an advantage by destroying neurons. That's an interesting idea, and it implies that one of the functions of pain, in addition to escaping predators, is to avoid infections. But the sensory neurons in peripheral tissues like hands and nose are destroyed by Mycobacterium leprae, the causative organism of leprosy. And there's good evidence that leprosy establishes a chronic disease in part by destroying neurons. So that answers at least that question. I did want to ask Robyn why she thinks pain evolved, and she really has gotten to this, and she mentioned the predation aspect of it. But the big picture, why do we experience pain at all? What's that all about?
Well, yeah, and let me just pull in. It was Carlo who had asked about the jewel wasps, and right, of course, jewel wasps have this amazing, ability to essentially do neurosurgery on cockroaches and then make them feel good, probably, right? As they are being zombified. So I think, when we're sort of thinking about pain and zombification, there are ways in which dulling pain can really benefit some parasites and, some infectious agents, which then I think makes it even clearer, right, that there's an evolutionary benefit to being able to feel the pain, right? If these parasites and these pathogens are interfering with it in ways that give them a leg up on us.
Yeah, for sure. I mean, pain is widely recognized as being protective. It's there to alert us to something going on. And pain sensitivity is kind of set by our early experiences such that we can correctly respond to what is happening around us. So people have different pain perceptions in part based on what's happened to them in their early life, because the goal of pain is to protect you from whatever is relevant in your environment. So why did pain evolve? It evolved because it protects us from harm. And it protects us in different ways to just having that kind of mindless, nociceptive reflex of immediate protection. It lets us remember contexts associated with pain. It lets us store memories for a really long time. It lets us attach emotional valence to bad things that have happened to us, such that we're very, very strongly averse to repeating those stupid mistakes. So pain is so obviously adaptive that it's clear that it should be present in most animals in some capacity. The emotional part of pain is obviously something important for animals that live a long time, because it helps us store long memories. All of this is sort of all feeding into this idea that pain is definitely protective. Pain can be bad for us as well, right? Chronic pain is bad for us, but in general, we experience pain because it helps us survive. That's just sort of one of the universal truths of pain perception. If you want me to chat about the zombie wasp, I actually don't know if the zombie wasp continues to feel pain. It's immobilized, it's paralyzed, but I don't know whether it doesn't feel what's happening to it. And it probably,
how could you find out?
I mean, you could certainly look at the nervous system responses. You could look at after injection of the venom from the jewel wasp, where it's a caterpillar, right, that they usually take.
There's many different parasitic wasps, but the case that Carla was asking about is when it zombifies the cockroach, and it puts this injection essentially, into the brain, which releases a bunch of octopamine, which is, the insect equivalent of dopamine. And, then the cockroach starts engaging in this grooming behavior and, presumably is, at least, enjoying itself a little bit, or whatever, at whatever level cockroaches can enjoy themselves after, that injection of drugs. So
I mean, that's a super important question. What does the cockroach know about its experience? Is it aware? Does it have conscious experience of what's happening to it? Or is it just this sort of, basic sort of reflex driven animal that's being manipulated by a chemical to perform certain behaviors? It's very hard to know what the internal experience of any other person is, let alone any animal. So I can't say for sure what the cockroach experience is.
It can't be good.
Probably not good. But it's hard to say.
What do you think is the case for cephalopods? Do you think that they have an experience of pain?
I think they do. Yes. It's been a big question in the world of sort of invertebrate welfare and ethics. These animals, these invertebrates that have quite large, quite complex brains, like crustaceans, like lobsters, all of the cephalopods, some other kind of more neurologically complex invertebrates. Why should they not have emotional processing? Just because they don't have a backbone, why should these kind of clearly adaptive things that are present in vertebrate animals, not have evolved in invertebrates? If they have the sufficient neural complexity, wouldn't it be naturally the case that they would also have some experience that is subjective when we consider how useful that is for us? Our research, I think, shows that the cephalopods do have some of that subjectivity. It might not be exactly the same as ours, but I don't think we can discount the idea that invertebrates are capable of pain and suffering, which has historically been the standard, that invertebrates don't feel. But I don't think that the more recent research is bearing that out. I think we need to reevaluate the way that we treat invertebrates, not just in research laboratories, but in fisheries, in environmental management, in all sorts of other ways where we would have concerns about vertebrate animal welfare. We probably also should have similar concerns for at least some of the neurologically complex invertebrates too.
We have a question from Kevin L. Kevin's asking, are there differences, major differences in terms of the evolution of pain, between vertebrates and cephalopods? So, where are the similarities, and are there any differences that we know about?
Yeah, and there's certainly a ton of behavioral similarities. The way that the animal responds to something that we as humans or as other mammals would feel painful, they respond in very much the same way. But whether that means that they have identical subjective experience is obviously a very difficult question to answer. And so, there's no harm in just assuming that they do and doing your best to protect them in that case. Are there any major differences? I mean, there certainly are differences in the wiring of the nervous system. There's differences in the molecular mechanisms as well, because we know that some anesthetics that work great on fish don't work at all on cephalopods. So there has to be molecular differences in the way that their pain nervous system is put together. But the degree to which the subjective experience is the same or different, that research is in sort of a very early stage, and it's hard to tell for sure what they really feel. But we're working on it. It's one of the things that we work on in our lab.
So do squid respond to opioids? I can't imagine they have an opioid receptor.
So that's actually an interesting question, because it's yet another controversy that 20 or so years ago, there were some molecular papers that came out suggesting that there were opiate receptors or opioid receptors in mollusks, so including snails and slugs and things. But recent transcriptome and genome data is very ambiguous on the question. There haven't actually been that many studies where people have given, opioid-like drugs to mollusks and seen a clear behavioral effect. One of the issues is that those have a lot of different effects. And sometimes it's hard behaviorally to separate out, is it just a sedating effect? Are you just poisoning the animal's nervous system, or is it actually dulling the pain? And so it's not a simple question. I see a question from Pamela here saying, don't most animals feel pain? That's a great question. Nearly all animals have nociceptive reflexes, which means that you can, if they touch something sharp, they'll withdraw away from it. But that's a very simple neural circuit that doesn't necessarily require central brain emotional processing. So nearly all animals have nociception. The issue for neuroscientists and from the perspective of welfare and just sort of generally of interest is how many of them have that subjective emotional state. We don't know.
So there's a couple of interesting questions here about social anxiety. So, many of us we can be zombified, right, by the pain of social anxiety. And Dave is asking, basically, is there a way to actually leverage infection or maybe microbes to overcome the pain of social anxiety? And Erica has some interesting responses here. She suggests first that maybe it's alcohol, which I should note is a microbial product,
there you
right?
go.
So, microbes may be playing some role there. And Erica also notes that, the parasite Toxoplasma gondii does seem to reduce at least the anxiety around approaching predators, which is probably not a good thing for the mice. But, we do have sort of these interesting ways in which infections are, changing the sort of emotional pain associated with interacting with others, whether those might be, potential predators or social others. So, how is there a way that we can kind of, think about these processes of zombification and pain and ultimately what is going on with how other organisms can potentially change our pain perception?
I feel like it's a really difficult thing for people to incorporate in their thought process, that our behavior can be manipulated by a disease process in the same way that we accept it happens, in mice not fearing cats, or in, snails climbing to the tip of a piece of grass to be eaten by a cow so they can, the parasite can complete their life cycle. I feel like there's a lot more resistance to us as humans believing that can happen to us, but there's absolutely no reason, evolutionarily speaking, why we can't be subjected to those same forces. So I don't know for sure if there's ever been any sort of definitive study of whether toxoplasmosis, which is something that definitely can infect humans, changes our behavior. I don't know. But that would be a good place to start looking, I would say.
It would be a great one.
Yeah.
So our earlier commenter, Kevin, is writing a review paper about the evolution of pain with me. And one of the things that we focused on was the effect of microbes in pain. So there are probiotics that we can take that do affect both anxiety and pain. Many of this research is done, of course, in mice. So whether that translates to humans is a little bit, remains to be seen. But microbes do affect these domains in kind of predictable ways. Pathogens like E. coli can increase pain and sensitize us to pain, whereas probiotics like lactobacillus, they can do the opposite, which is totally cool. And also getting to the Dave's point, he talked about using diseases to treat pain. When microbes do things that we think are good, we call them probiotics, not necessarily diseases. But you can also treat pain with antibiotics, or pain is sensitive to antibiotics too. That's been shown, as well as social behavior. Again, mouse studies. Antibiotics can decrease some of the adverse pain sensitization that happens with opioids.
Yeah, definitely. I mean, it's such a complex area. And I think there is emerging awareness of this thing called the gut-brain axis, which is that gut microbes and what's happening in our holobiont, which is all of us, including all of our microbes, can have very profound effects on behavior. So perhaps we're moving more towards recognition that human behavior is not just a product of our own sort of free will and decisions is also manipulated by everything else that uses us as a host, whether that's, the things that naturally live in our gut, or whether it's a pathogen or, anything at all. Certainly pain is one of those things that's very strongly modulated by our environment.
Well, that might be a good place for us to wrap things up. I wanted to ask you, Robyn, what is your favorite octopus or squid or nautilus? What is your favorite cephalopod?
What is my favorite cephalopod? I do have a soft spot for nautiluses because they're so kind of ancient and weird, and they're just so not the glamour child of the cephalopod world, because they're a bit dumb and they're deep water and they don't do that much. So I do have a bit of a sentimental attachment to the nautilus. So
they are genuinely amazing. And Athena, any last comments before we head out?
I mean, this was just fascinating and amazing. And I think, just kind of coming back to these, big picture questions about pain. I mean, the fact is, and, Carlo mainly brings it up here, given that pain helps us, it seems like, all animals should have it on some level, right? And then, some animals can potentially benefit from interfering with it if that can change the behavior of organisms to make them, serve the fitness interests of the organism that's doing the manipulating. So I think this whole issue of pain and the different ways that we as organisms affect each other and affect pain perception is just such a cool area of study. So so many questions, and we already have requests in the comments for a part 2 about pain. So we may have to have you back.
Awesome.
Well, Robyn, thank you so much for joining us for this episode of the Dr. Zed Show. I do also hope that we can do this again sometime in the future.
Yeah, it's my pleasure. Thank you so much for giving me the chance to think more about zombies. It's not something that is in my regular awareness, so it's been fantastic. Thank you, guys.
Thank you. And now zombies are a part of your consciousness. Good stuff. And so for this episode of Dr. Zed Show, we're going to sign off until next time.
It's crazy, but it seems so logical. I can't deny that there is something supernatural with you.